Good. I think everyone in the room can hear me okay? Yep. Perfect. No need for an extra mic then. So, good afternoon. Welcome everyone here in the room and also online streaming with us today. My name's Chris Plant. I'm with AWS and I look after the Grab relationship. So on behalf of AutoMQ, our event hosts today, they've asked me to say a few words just to thank some of their partners who've made this event available today. So first of all, AWS Singapore, well, I can say on behalf of AWS, we're nothing without our partners in the ecosystem. So don't thank us, thank yourselves for being proactive and being part of the ecosystem. Secondly, Grab. We've got a couple of keynote speakers from Grab who are going to share some of their thoughts around the implementation and success they've had with AutoMQ. So thank you for taking time out of your weekend and joining us. Next is the Stream database, Time Plus, who've also helped to promote and make this event available. The technical writer, VU, and then CSDN and DESG for promoting the event online. So we've got roughly 2 hours of content for you today. We're going to be kicking off with the team from AutoMQ, who will do roughly 40 minutes, just sharing a bit more about the solution, its capabilities, how they are bridging streaming and analytics with Iceberg. We're then going to hand over to our very own Jerry, who's going to provide a recap of AWS reInvent, which was the first week of December in Las Vegas, which is our annual event and typically is synonymous with us releasing new features and capabilities to many of our native services. And Jerry's also going to take about 40 minutes and just give us some of the headlines there. And then last but not least, we'll have our 2 speakers from Grab who are going to share a little bit more about how they're driving data efficiency within their data streaming platform with AutoMQ. So that's roughly 2 hours between speaker changeovers. Please feel free. There's tea and coffee out at the stations. There's also some fridges with cold drinks. So please help yourselves. The ladies and gents facilities are down the corridor. And if there is a emergency or fire event, please just follow the green signage and listen to the instructions over the intercom. With that, brilliant. Can I hand over to AutoMQ? Thank you.
Thanks, Chris. Wait. Hello, everyone. Thanks for being here today, and wish you have a good time with AWS, Grab, and AutoMQ. And I'm also very excited to share something with you about the AutoMQ and its latest feature, table topic, and how we bridge the gap between the streaming and analytics with Apache Iceberg. Yeah. So before we start, let me introduce myself. And my name is Xinyu Zhou, and I'm the co-founder and CTO of AutoMQ. Actually, AutoMQ is AutoMQ company is a cloud Apache Kafka cloud provider which provide cloud native Kafka service. And before founding AutoMQ, I worked for Alibaba Cloud almost 7 years, and where I was responsible for messaging and streaming products of Alibaba Cloud. And also, I'm very active in open source community, especially Apache community. I'm one of the members of Apache Foundation and PMC members of Apache RackNQ and Incubator, and also I'm mentoring a new Apache project named Apache Omoro, which is a data lakehouse management system for modern data lake. So if you are interested in any mentioned projects, please feel free to join these communities. Yeah. So now let's focus today's topic. And today I will discuss my topic in 5 parts. First, I will introduce the AutoMQ and the evolution history of the streaming world. And then we will deep dive into the architecture of AutoMQ and its advantages over Apache Kafka or other Kafka commercial services. Yeah, then I will introduce the AutoMQ table topic and explain how to integrate it with Apache Iceberg along with the AWS latest product S3 tables, which was announced at this year's reInvent. And then I will demonstrate how to use the AutoMQ table topic to unify the streaming and analytics on the AWS Marketplace. Finally, there will be a simple summary and the roadmap of the table topic. So let's move to the first part. So what is AutoMQ? And basically, AutoMQ is a cloud-native alternative to Apache Kafka. We have rewritten the in-house storage layer of Apache Kafka and with cloud storage services like AWS EBS and AWS S3. Also, AutoMQ is a source available project. You can start and clone it from the GitHub. So far, we have more than 4,000 stargazers worldwide, and also over 40 co-contributors from different companies like AutoMQ, Grab, and Zhihu, Renault, Jingdong, and so on. And so welcome to join us, and any contributions are welcome here. So let's look back at the evolution of the streaming world, which is involved for more than 10 years. Yeah. Apache Kafka is beginning since 2011. It has been open sourced by Nikim, and its excellent performance and classic shard architecture have resolved the scalability issue in the on-premise environment. And then it has been adopted by a large number of companies and gradually became the de facto standard for stream storage. So you know that there will be many commercial opportunities behind a successful open source project. So we saw the Confluent and the Redpanda. These companies are leading the technical innovations for Apache Kafka. For Confluent, the biggest innovation is K-route and the tier storage. While the K-route removes the dependency on Zookeeper and makes the architecture cleaner, and the tier storage can reap the capabilities of object storage and lead to reduction in cost of the storage. And the Redpanda has rewritten the Kafka in the native language C++ and uses the Raft replication protocol instead of the Kafka ISR protocol, so leading to further improvements in performance. But basically, both the Confluent and Redpanda adopt a shared NAS architecture with tiered storage optimization. So regarding the architecture, there are no big differences between them. So today, cloud-native technologies are reshaping the infrastructure software. Over the past 2 years, in the realm of the stream storage, there are two companies have emerged, WarpStream and AutoMQ. Both have successfully implemented a cloud-native Kafka and have achieved an impressive tenfold reduction in the cost. So WarpStream is built directly on S3. Its architecture is very clean, but however, the latency has been sacrificed, and the end-to-end latency of WarpStream is more than 1 second. Another concern is about the compatibility. WarpStream has rewritten the Apache Kafka from scratch, which is really a big challenge since Apache Kafka has more than 1 million pull lines. So far, there are many APIs of Apache Kafka are not supported by WarpStream. Also, AutoMQ also stores data internally on object storage, but we have adopted a different architecture. By decoupling the computation and storage, we offload the storage to EBS and S3, and maintaining the full compatibility with Apache Kafka without any performance sacrification.
The slides are not moving online.
Okay, sorry about the interruption. Now everything is okay now. So let's back to my talk. And next, let's deep dive into the cloud-native architecture of AutoMQ and its advantages over Apache Kafka and other Kafka vendor services. So how did we achieve the cloud-native architecture of AutoMQ? The most important part is nice in the storage layer. And we have developed a shared stream library called S3 Stream, which combines the EBS and S3. While EBS will serve as a word storage and S3 serve as a data storage. So there is no data replication. That's because the EBS already has has in the multiple replicas for ensuring the durability. And while S3 has erasure code to ensure durability to provide more than 11 lines durability. So we don't need to replicate data anymore. And you may wonder that's why we need two kinds of cloud storage like EBS and S3. That's because there is no single type of cloud storage can meet the needs of the stream storage. The stream storage need to be low latency, high throughput, and low cost. While S3 almost meets all the requirements of the stream storage, but it has high latency. Actually, S3 is not optimized for high LPS and low latency scenarios. So, on the other hand, the EBS offers sub-millisecond latency, but its space is very expensive. Therefore, we use the EBS as a wall storage and S3 as a data storage. And each block of the AutoMQ only requires a 10 GB EBS volume for the wall storage. The cost is negligible. Actually, the monthly cost of a 10 GB EBS GP3 volume is less than $1. Yeah. So now we have the S3 stream storage library. The next step we can replace the Intel storage layer of Apache Kafka with the S3 stream. So then we can transform the architecture of Apache Kafka from the shared nothing architecture to the shared storage architecture, and makes the architecture stateless. So once the block comes stateless, we can deploy an AutoMQ cluster very easily, just like deploy a stateless microservices. Yeah. So even we can even employ support instances to deploy an AutoMQ cluster. So it's very easy to set up an AutoMQ cluster. So finally, we can automate everything to achieve an elastic architecture. So through collecting key metrics from the cluster, we have two automated controller. The auto-scaling controller will watch the loads of the cluster and makes the decisions to scale in or scale out the cluster based on the workload. The auto-balancing controller minimizes hotspotting issues by dynamically reassigning partitions across the entire cluster. So you may wonder that why AutoMQ can claim its architecture is cloud native. That's because we are deeply leveraging the capabilities of cloud native, like the durability of cloud storage services. So we don't need to replicate data anymore, and the multi-touch ability of EBS for failover. And if EBS is failed, and we can just use the multi-touch ability for recovery. Also, the elasticity APIs of cloud for provisioning resources, so we can achieve an elastic architecture through like ASG. Yeah. So also we can even employ the support instances to deploy the AutoMQ cluster. So this is why we can claim our architecture is cloud native. Yeah. So you may find that the core components of AutoMQ is the S3 stream, so which is responsible for data writing and reading. So the data from the producer is stored in the wall storage processing and then uploaded to object storage in nearly real time. The consumers can access the data via S3. Of course, there is a block cache for acceleration, so the returning real consumers can just fetch the latest data from the block cache directly. So there is no need to access the object storage for turning real consumers. So actually, the S3 stream consists of a wall or shared wall storage and the object storage. But also, we can have many different implementations for wall storage. So it's very flexible for us to compensate the differences of cloud storage abilities among various cloud providers. So for example, almost all the top cloud providers offer EBS storage, so we can just use the EBS as a wall storage implementation. And some of cloud providers like Azure, GCP, and AWS Cloud even offer regional EBS, so makes it a good practice to use the regional EBS as a wall storage. And what's more, if your business is latency relaxed, or you have a mini I/O setup based on high performance devices like NVMe disks, so you can just use object storage as your wall storage. So that means the Intel architecture that's only dependency on object storage. Yeah. So you may get it that we also provide a work stream like architecture if you need it. Yeah. So this is the S3 stream. So there are many advantages of AutoMQ, and the most important one is about the cost. AutoMQ can reduce the 90% of cost of both the computation and the storage. For storage, AutoMQ replaces 3 replication EBS storage with a single replica object storage, which is 20x cheaper. And for the compute, AutoMQ's elastic architecture can prevent over-provisioning. Also, we can employ the support instances to deploy AutoMQ, so which can lead to a 90% reduction in costs. And what's more, the AutoMQ's stateless architecture greatly enhances the operational efficiency. And for AutoMQ, the partition real-time partition no longer involves the data replication, so which can be finished in seconds. Unlike in Apache Kafka, it may take up to several hours. Yeah. So for when it comes to the cluster scaling, and AutoMQ can balance the traffic workloads of the new nodes among the Intel cluster in 1 minute. In contrast, it may take up to days with Apache Kafka. So, and maybe the most important is about the compatibility. Yeah, AutoMQ replaces the Intel storage layer of Apache Kafka while keeping all the computation code of the Apache Kafka. So we can easily ensure the fully compatibility with Apache Kafka. Actually, we have passed all the end-to-end tests of Apache Kafka community, and also with AutoMQ support all the KIP features and all the version, all the Kafka client versions, and from the very earliest Kafka versions here. So actually, for example, the latest feature of Apache Kafka, like compact topics, idempotent producers, and the transactional messages. Both these new features of Apache Kafka are fully supported by AutoMQ. Actually, we have replaced the storage layer through a very small log segment aspect, and that means we can synchronize the code from the upstream very easily. So that means in the future we can support the newest feature of Apache Kafka very easily, which unfortunately it's a big challenge for many Kafka vendors. Yeah. So this is about the advantages of AutoMQ. So now I'm going to introduce the latest feature of AutoMQ, the table topic, and show how to integrate it with AWS S3 tables and Iceberg. Yeah. Before that, I want to share our innovation about the data architecture, and we can observe a trend that all the data-intensive applications will eventually store the data on the object storage. But however, even though all the systems will store the data, all the data is stored on object storage, but there is no simple way to share the data between different systems. So the ETL jobs and the data format conversion are needed here. So and so we see the transition from the shared storage architecture to shared data architecture as the next critical steps for modern data technology. Yeah. So the open table formats, the table solutions like Iceberg gives an opportunity to implement a shared data architecture. So you imagine shared data architecture of AutoMQ, the data is firstly generated in the streaming manner and appended to the stream storage. So the Flink jobs, the Spark jobs, or the Kafka consumers can manage the real-time value of the stream data through the Kafka APIs. So once the data loses its freshness, the table topic feature can convert the stream data to the table format. So the Intel big data technologies can access the data through a zero ETL approach. So there is no ETL jobs needed here. So this is what we imagined for the shared data architecture. So now let's have an in-depth look at the table architecture. Table topic architecture. Basically, table topic is a new type of topic of AutoMQ, which is a hybrid of stream table and the iceberg table. So there are three core components of a table topic. The first one is about the schema and the catalog management. And AutoMQ supports built-in Kafka schema registry, and also we support automatic table creation and automatic schema evolution. Currently, we only support AWS Glue and the table bucket as the catalog services. So the core component of the AutoMQ table topic is the table coordinator. Each topic has a table coordinator and always run along with the partition 0, and which is responsible for centralized coordination for iceberg snapshot submissions, and which can reduce the commit frequency and avoid performance conflicts. So the third component is the table workers. And each broker has many embedded table workers, and each table worker will hold an iceberg writer and is responsible for writing all the stream data of a specific topic to iceberg table format. And also the table, all the table workers of a same broker will share the same data cache to reduce the resources usage. And also the AutoMQ table worker will handle data uploads by listening to commit request events which is emitted by the table coordinator. Yes, so this is the architecture of table topic. So now the AutoMQ kernel both supports stream storage and table storage, so we can ingest the data from many data sources and store the data and the table format. And now almost all of the compute engines like Spark, Hive, Flink, and Presto can access this data through a zero ETL approach. As long as the compute engine supports the iceberg format. So there are many benefits of AutoMQ table topic. The first one is that it's very easy to set up the feature, and we don't need to the Flink jobs. There is no Kafka connect, and there is no extra configurations. Just a single click to set up the table topic feature. Also, we provide built-in schema registry. And once you have an AutoMQ cluster, you will get an endpoint of the schema registry and just use it in your Kafka client. In your Kafka client, and everything will work as expected. Also, we support the auto creation of iceberg tables and automatic schema evolution. And maybe the most standout benefits is the elimination of traditional ETL pipelines, which can reduce the cost and the operational complexity. So, and you know that the AutoMQ is a elastic architecture. So the table topic is a built-in feature. So the table topic can leverage the auto scaling and the auto balance controllers to auto scale the table workers. Also can balance the workload of the workers automatically. The next one is about the seamless integration with AWS S3 tables. So we can utilize the S3 tables abilities like high performance, the integrated catalog, and the table maintenance. the table maintenance is very important for us. So AutoMQ, because we have S3 tables, AutoMQ don't need to worry about the data compaction and the garbage collection and even the snapshot management. So it's a very important feature for the AutoMQ table topic. And also, AutoMQ seamlessly integrated with AWS analytics products like AWS Asana, the EMR, the Redshift, or the QuickSight. Yeah. So now let's see table topic in action, and I will demonstrate how to use this feature on the AWS Marketplace. And the first step, you should subscribe to AutoMQ from the AWS Marketplace. And AutoMQ provides bring your own cloud, also claim the BYOC model, so you can install the Intel AutoMQ cluster in your account, in your VPC. So after the subscription, and you can install the AutoMQ control plane in your VPC, and you will finally get a URL to access the control plane with an initial password. So after logging with the password, you can create an AutoMQ cluster with S3 with table topic feature enabled. But remember that before that, you should visit the S3 console to create a new bucket type, the table bucket, and record its ARN and associate the ARN with the AutoMQ cluster. Then you can create a test table topic. It's very easy. Just enable this feature when you are creating a topic. Yeah. So after creating a test topic, we can prepare some data and send it to a table topic. We adopt a schema of click stream data, which has many columns like tenant ID, unit name, and unit time. And then we can send the click stream data via Kafka producer to the test table topic. So after sending the data, we can query the table data from the AWS Asana. It's very easy. Just use the simplest SQL to select all the data from the table, and you will get the result in seconds. Yeah, it's very easy to. So this is a simple example to show how to use AutoMQ and AutoMQ table topic with AWS Asana. So let's move to the final part, and there will be a simple summary and the roadmap. So I guess you may aware that today's talk is about evolution history. Yeah, the Apache Kafka was born 10 years ago with a shared NAS architecture, and the AutoMQ transferred the architecture of Apache Kafka from the shared NAS into shared storage to reap the cloud storage capabilities like EBS and S3. And then the Iceberg, the open table format like Iceberg gives an ability to support a shared data architecture. So, which is why we introduce the table topic to achieve a shared data architecture. So this is a data architecture evolution history. So of course, it's not the end of the table topic. In the future, we will more features of the table topic. The first is about we will support more catalogs. Currently, we only support AWS Glue and the table bucket. In the future, we will support Hive Metastore and the Iceberg REST catalog for the catalog services. Yeah, mostly, maybe it's important to implement the row mutations and the absolute model, and which can enable the table topic to handle CDC scenarios easily. Yeah, actually, this feature is waiting to release. Yeah. And the most important about the part is about the table maintenance. Actually, even though the AWS S3 tables already has a built-in table maintenance feature, but not all the cloud providers provide the S3 tables. So the AutoMQ also should provide the built-in table maintenance like compacting data files, expiring snapshots, removing old metadata files, even deleting the orphan files. So okay, this is all my presentation. And if you want to further learn about the AutoMQ and the AutoMQ table topic, you can scan the QR code to join the AutoMQ Slack channel. Also, we have many documents in our website, so you can visit our website for more details about the AutoMQ. So thank you. That's all about my presentation. So any questions are welcome here. So if there is no question, we can move to the next part.
What's the use cases for AutoMQ?
Okay.
Any use cases?
Use cases. Okay. Okay. The graph will share the use cases of how to use AutoMQ to replace Apache Kafka. Also, in China, there are many big companies like Geely Auto, Jingdong, Renault are using AutoMQ in the production environments, very large scale. Yeah.
So it's basically to manage the data for the applications.
Application. It's. I'm sorry, you.
I mean, AutoMQ is basically to actually manage like the data.
Yeah, the data stream application like Flink application, Spark application. Yeah, it's.
Yeah.
Okay, thanks. So let's have Jerry. Yeah.
Thank you. Thank you, Xinyu.
So give me some time. Yeah.
Hello? Okay. All right. All right. So, thank you everyone. And maybe before we get started, let me also introduce myself. My name is Jerry, from AWS Solution Architect team. And currently, I'm looking after those top tier of Web3 customers, and previously I was also working with some sort of digital native business customers, like let's say gaming industry or e-commerce and social app. Okay, so when it comes to today's section, first of all, I'm pretty proud to be joining this session, and I'm going to share some updates about our AWS re:Invent 2024. So which is the maybe one of the largest technical events or in our developer community. Okay, so in terms of today's content, I have picked up some updates of products or features in terms of data and AI perspective. So the first part is about foundation models. Within this event, AWS has launched the new generation foundation models, which is called Nova, and actually is a new generation of the SOTA foundation models that delivers frontier intelligence and basically the industry leading price performance. Okay, so as you can see at this slide, basically we are having maybe two types of foundation models. One is the left hand understanding models, which is maybe somehow text-based, and the next one is the creative content generation model. Maybe you can simply understand that to generate image or generate videos. So I'm going to share some more examples of these models. Okay, then maybe when we take a closer look at the understanding models, we are having these 4 types, which is Amazon Nova Micro, Lite, and Pro. And these 3 models are already generally available. Yeah. And for the premium, it's coming soon, and actually it's our most capable multi-model models for complex reasoning tasks. So let's wait for it. And in terms of Micro, Lite, and Pro, basically you can enjoy the lowest cost and latency at Micro, and but relatively lower intelligence level, and maybe you can enjoy the higher intelligence level at Pro. So maybe you can choose on your own. Okay. Okay. Oh, sorry. Okay, so here I'm going to share some more examples about our creative content generation models. The first one is the image model. Maybe you can see it to generate image through text or through image as inputs. So you can see here, I just give the model as a prompt there, a portrait of a smiling young woman with long flowing hair standing in natural sunlight. Okay, so the output is at the right hand. Okay, so you can see it. You can clearly see the image is quite real and realistic. And maybe we take a closer look at this sunlight effect. It's quite natural. So, and no matter the face expression and the light effect, yeah, it is quite real. Okay, so this is the effect of our image models. And then, okay, and here I'm going to share some examples of our video generation models. And yeah, the same, you can use text and image as inputs. And I'm gonna show you example respectively. So the first one, yeah, it's basically generated through a prompt. Maybe the prompt text is too small to read, and maybe I'll read for you. Cinematic body shot. Okay, this is a very professional filming technique. Okay, the filming technique, and of a juicy cheeseburger. Okay, you can see the cheeseburger with melting cheese, fries, and condensation covered cola on a warm diner table. Okay, and natural lighting, visible steam. Yeah, you can see the steam right here. And also, I also described the video resolution, 4K, and photorealistic shadow depth of field. Okay, this is the prompt. So yeah, you can see the effect is quite amazing. And I think all of you have done your lunch already, right? Otherwise, maybe you must be feeling hungry. Okay, this is the first example, and I'm gonna show you another one. Okay, this is also generated through a very simple prompt: noodles falling into a bowl of soup. Okay. All right, another example. Okay, you can see here, this is a static image. Okay, static image only. So I'm gonna show you a video purely generated through a prompt, and that can make a video based on this static image. Okay, the similar prompt, dolly forward, yeah, based on previous image. So you can see the video is generated through from the just static image. Yeah, so the effect is quite amazing. All right. Yeah, above is quite a few examples for your reference, and I have also prepare some other examples or blogs, maybe model cards, yeah, for reference for whom maybe more interested in. All right. So above parts, I just shared some latest foundation model updates. But maybe if we take a higher look, when we are ready to build and develop our AI application securely and responsibly, but where do we start at AWS? Actually, we are not just providing a foundation model only, and yeah, as you can see here, we are providing 3 layers of AI stack. So maybe just take a look from the bottom to the top. From the bottom, we are providing infrastructure level of resources. Say for example, GPU instance and some specific AI specific chips for you to do the maybe training job, maybe do the inference job. Yeah, like shown here is Trainium and Inferentia. And the SageMaker, yeah, SageMaker is also a well-known AI platform. But after this reinvent, AWS has also redefined SageMaker's role and responsibility. And I'm going to show you some information about SageMaker as well. So, okay, yeah, this is for the infrastructure level. So on top, we are providing you the PaaS service, which is Bedrock. We have integrated many well-known third-party foundation model for yourself, and for customer, you just only need to simply integrate Bedrock API call that you can very easily to call the foundation model. Yeah. Okay. This is for the PaaS application. So on top of that, we are also providing you some AI empowered application like AutoMQ. Maybe let's say for example, AutoMQ developer is an IDE tool for developers that can easily integrate it into your IDE local IDE tool. Say for example, Visual Studio Code or PyCharm, yeah, that sort of tool. For the developers, they can use it for maybe code generation, maybe code review and some code summary, yeah, that sort of things. Okay, so yeah, so that which means AWS is providing you a full AI stack, not just foundation model. So for a customer, they can choose on the demand and scenario based for their own. Okay, so the next part, I'm going to say something about SageMaker. I think maybe some of you are familiar with SageMaker. Before, SageMaker is a purely AI platform throughout machine learning lifecycle. Maybe model development and model training and for model deployment. Okay, and so that's all about machine learning only. But today, SageMaker actually has been redefined into a unified studio. Okay, so I think you may be asking what is unified and what are integrated. So that's all here. For data processing and for SQL analytics and also model development, Gen AI application development, and some BI business intelligence capability as well. So you can understand that we have taken SageMaker as a unified platform, not only for AI but also data as well. So when we take a closer look, you can easily see here within the Unified Studio, for the maybe machine learning developers or data engineers, they can use SQL ID tool to maybe do some data manipulation work, like do some query and do some ETL job. And for machine learning engineers, they can also do some generative AI application development with Bedrock, also in this Unified Studio. So yeah, and thirdly, maybe for the data governance, yeah, through our whole life cycle, yeah, the Unified Studio also help you to do that. And the second part is talking about some open data. Maybe for this content is called Apache Iceberg Open API. You can understand that I think this is a signal that AWS is going to open or to make their data as a data market to be open to not only just AWS specific application or AWS specific service, but also for third-party applications. So for you, maybe that, which means you can choose your analytic engine, which is Apache Iceberg supporting. Yeah, then you can easily manage your data and query your data through this Apache Iceberg Open API. And for sure, AWS also launched a brand new table format, S3 tables. And at the just previous section, I understand that AutoMQ also supports these table formats, and thank you very much for keeping so close with AWS. And so maybe alternatively, you can understand that this table format is a full managed Apache Iceberg table in S3. So what are managed by AWS actually is some table maintenance job. Let's say, for example, small files compaction and maybe metadata management. Yeah, those are managed by AWS. So for you don't worry about your small files compaction, and you don't worry about the metadata management. Yeah, so that's a brand new table format. Okay, all right. So and in terms of the metadata, like I said just now, AWS manage the metadata for you. So we have also opened the API of metadata. So which means you can directly query your table metadata through SQL. Yeah. Previously, we just offer some kind of API on group catalog. Yeah. But yeah, right now, from now on, you can more easily to manage your metadata, and maybe I think it's a great brand new method for you to somehow to query your data statistic. Yeah. Okay, maybe the last part, I'm going to talk something about Aura. It's our database. Okay, all right. So in Remain 2024, we have launched a completely serverless distributed SQL database, which is called Amazon DSQL. Maybe I'm going to show you some specific architecture. In terms of the deployment model, DCCO is providing two types of deployment model. One is single region cluster. So even is a single region, but it's also multi-AZ deployment. Okay, so your data is replicated across 3 AZs, and but no instance to manage. It's a completely service application. So for application, just need to maybe integrate the endpoint. Yeah, integrate the endpoint. So maybe in terms of the auto scaling and in terms of the capability underlay, AWS manage it. Okay, so maybe in terms of the data persistence, the mechanism is this transaction will only return success after the data or maybe the logs are persisted into 2 out of 3 AZs. Okay, so which means we can keep a very high data persistence level. Okay, so maybe when we take a look at multi-region, that functions or works very well. In this multi-region cluster, so similar scenario, maybe let's say for example you have application deployed in 2 separate regions, and under this scenario, the data replication workflow is like shown here. We have 2 regions, and we are also having third witness region. That is an underlay region. You cannot maybe do some work on this region, but for this region, the typical role is working with the data replication. So like I said just now, the transaction will only return success after the loss is persisted into 2 out of 3 regions. Okay, so this design is for maybe high availability and also very high level of data persistence. So you can enjoy typically RPO 0 when disaster occurs. Okay, so this is our DCCO, very amazing design. Okay, maybe that's all of my parts, and last but not least, I also prepare some other release for you for reference, not only the content above. Yeah, so maybe something you may be interested in, you can check this one. Okay, yeah, that's all of my part. Any question?
For your IDE, just now, the IDE, is it like standalone kind of application I can work offline, or I have to be logged in my Amazon account, AWS account?
You have to, first of all, you have to own an AWS account, but for the integration, you just need to maybe generate a AKSK, SS key and security key.
I mean, it's not, I have to, it's hosted on the server, it's not a desktop application that I can download and work with, like IntelliJ and those IDEs, you know.
You don't have to download something, but
So
yeah.
I have to be online.
Yeah. Okay. So thank you very much. Maybe move on to break or. Okay. Okay.